Hello everybody. In today's lecture, I am going to discuss the equation which can be reduced to linear form. Actually, this type of equation is also known as Bernoulli equation. The equation which is of the form dy by dx plus p into y is equal to q into y to the power n, where p and q are the function of x, can be reduced to linear form by dividing the whole equation by y to the power n. Okay, if this is the equation dy by dx plus p into y is equal to q into y to the power n, then how we can reduce this nonlinear equation into linear form? We have to divide the whole equation by y to the power n and then substitute the coefficient of p, which will be in this case y 1 upon y to the power n minus 1 with a new variable z, and then you have to proceed. Okay, so let's see what will happen if we divide the whole equation by y to the power n. This equation will become like this: 1 upon y to the power n dy by dx plus p, where p is a function of x, okay, into y divided by y to the power n. That means it will be y 1 upon y to the power n minus 1 is equal to q. We are dividing by y to the power n, so in the right hand side only q will left. Got it? Now in the second step you have to substitute the coefficient of p, that is in this case 1 upon y to the power n minus 1 is equal to z. Clear? Now find dz upon dx. When z is equal to 1 upon y to the power n minus 1, that means z is equal to y raised to the power minus n minus 1. Okay, you can write this like this also. Now find, this can be written as y to the power 1 minus n. Okay, now find dz upon dx. Dz upon dx will be, we are differentiating the whole equation with respect to x. In the left hand side it is dz upon dx, and right hand side first you differentiate it with respect to y, and then again you differentiate y with respect to x. Is it clear? If you differentiate this y to the power 1 minus n with respect to y, what will happen? The power will come first, so 1 minus n, okay, and its power will decrease by 1. So 1 minus 1 into y to the power minus n, only minus n will left, into dy by dx, because we are differentiating with respect to x. This is a function of function, so we have to apply the chain rule. First differentiate it with respect to y and then y with respect to x. So dz upon dx will be 1 minus n divided by y to the power n into dy by dx. Okay, so this is your dz upon dx. Now what you have to do, you substitute the value in this equation 2. Okay, in this case, okay, 1 upon y to the power 1 upon y to the power n dy by dx, what will it will be? It will be, this term will come in the denominator, so it will be 1 upon 1 minus n dz upon dx. Okay, this whole term is this one. Is it clear? If you write y to the power minus n in the form of denominator, it will be 1 upon y to the power n dy by dx. So its value is this 1 minus n will come here in the denominator. So 1 by 1 minus n dz by dx. So this value will be 1 by 1 minus n dz by dx plus p into z, you have substituted this value as z, so p into z is equal to q. Okay, so now the second attempt is make this dz by dx coefficient should be 1, so multiply the whole equation with 1 minus n, it will be dz by dx plus p into 1 minus n into z, where p is a function of x only, is equal to q into 1 minus n. Is it clear? Now this is a linear differential equation which of in z. Your y is got replaced with z. So dz by dx plus p, where p is whole function of x and with some constant. So this is whole p. P into z is equal to q. Q is again a function of x only, and this is some scalar quantity 1 minus n. Okay, whatever it is. So now this equation, this very equation is your linear equation in z. Now you can solve it by finding the integrating method which we have discussed in the last lecture. Find the integrating factor and then you get your solution. Now let's see one question. In exercise 5 of your book in page number 341, the question number 1, it is like this. Solve the following differential equation. Here you can see this is given dy by dx plus y by x is equal to y square. Clear? So this is dy by dx p into y, where p is 1 upon x, p into y is equal to q is here constant, okay, and into y square, that means q into y to the power n, here n is your 2. So this is your q is not alone, q is multiplied with y to the power n or y square. So this is your Bernoulli equation. So you can reduce it into linear form by dividing the whole equation by y to the power y square. So if you divide this equation by y square, what will happen? First term, it will be 1 upon y square dy by dx plus 1 y will cancel out. This y in numerator will get cancelled with y square in the denominator. So it will be 1 upon xy is equal to 1. If you multiply this with divide this equation with y by y square, then in the right hand side it will be only 1. Okay, now the second step was whatever coefficient is p having, substitute that equal to a new variable z or v, whatever you want. Okay, so here p is your 1 upon x. Okay, p is your 1 upon x, p into y. So here the coefficient of p is 1 upon y. So substitute 1 upon y is equal to z. Now differentiate with respect to x. The right hand side it will be dz by dx. In the left hand side it will be minus 1 upon y square dy by dx. Okay, this is 1 upon y. So, or you can say it is y raised to the power minus 1. So when you will differentiate it, it will be minus 1 y to the power minus 1 in minus 1, that is minus 2 dy by dx. So this is minus of 1 upon y square dy by dx is equal to dz by dx. So dz by dx, okay, so you have to replace this value now. This value you have to replace with in terms of z. So 1 upon y square dy by dx, here you can see it is minus of dz by dx. So substitute this value as minus dz by dx plus 1 upon xy, that is 1 upon x into z is equal to 1. Okay. Now see, this is your equation. Now you just multiply with minus 1 both side. It will, what will happen, it will be dz by dx minus of 1 upon x into z is equal to minus 1. So now this is linear. Okay, where p is a function of x only and its value of p is minus of 1 upon x, and q is constant, that is minus of 1. So this is linear in z. Now we can find the solution of this e- equation by finding the integrating factor. What will be the integrating factor here? In this case, e to the power p dx, where p is minus of 1 upon x, that is minus of 1 upon x dx. Okay, this is your integrating factor, p dx. P is minus 1 upon x. So p dx, that is equal to e raised to the power minus of, this value is log of x. You can this, bring this sign in the, in terms of power of x. So it will be x inverse, or you can write e log x inverse, means x inverse only. So integrating factor will be 1 upon x. Okay, this is your linear equation and its integrating factor is this x 1 upon x. So the solution will be z into, here if it is dy by dx, then the solution is y into integrating factor, but here this is linear in z. So z into the integrating factor is equal to integration integration, sorry, q dx, q into integrating factor into dx. Q is minus 1, here q is constant, this is not function of x, this is constant. So q is minus 1 into the integrating factor, that is 1 upon x dx plus c. This is your solution. If you simplify it, what will happen? Z by x is equal to minus of 1 upon x dx plus c. And what is the value of 1 upon x dx? 1 upon x dx, this is your log of x. So the value will be z by x is equal to minus of log of x plus c. So this is your answer. So what is the working rule to solve the Bernoulli equation? First, I am repeating, you just divide the whole equation, Bernoulli equation, by y to the power n, the coefficient of q, that is y to the power n. Here y to the power, divide this whole equation by y to the power n, then substitute the coefficient of p, whatever it will come. After dividing y by y to the power n, whatever value of y comes as a coefficient of p, you substitute that term is equal to z, and then find dz by dx. Okay, and substitute this value over here, and you will find that this equation will become linear equation in z. Then find the integrating factor, e raised to the power p dx, and then you it will up, and then you solve the differential equation by the same method which we have discussed in the last turn, that find the integrating factor and then find the solution directly without any substitution or elimination. Now better we move to the next question, question number 3. Now you can see that it is given that dy by dx minus 2y tan x is equal to y square tan square x. Okay, now this is your p. What is your p? P is your minus 2 tan x. Dy by dx, so p is minus 2 tan x into y, that is p into y is equal to q into y to the power n. Q is your tan square x, again function of x, into y to the power n. That means you have here in this case n is 2, so y square tan square x. So q into y to the power n is tan square x y square. So divide the whole equation by y square. So what will happen? It will be 1 upon y square dy by dx minus 2 by y tan x is equal to tan square x. Now second step, you have to substitute the coefficient of p. The coefficient of p in terms of y, that means minus of 1 upon y, or p is minus 2 tan x, so its coefficient is 1 upon y, so substitute 1 upon y is equal to z, so it will be minus of 1 upon y square dy by dx is equal to dz by dx, so only 1 upon y square dy by dx will be minus of dz by dx. So substitute here 1 in place of 1 upon y square dy by dx, we will write dz minus of dz by dx. So write minus of dz by dx minus of 2 minus of 2 tan x into z, 2 tan x into z. Here it is dz by dx, so with p there will be z in multiplication, p into z. So p is your minus 2 tan x into z is equal to q. Q is again tan square x. Okay, now make this into the standard form of linear differential equation, that is dz by dx plus 2z tan x is equal to minus of tan square x, where p and q are the function of x only, and the value of p is 2 tan x, and the value of q is minus of tan square x. From here we can see the value of p is 2 tan x and q is minus of tan square x. So find the integrating factor. Integrating factor will be same as e raised to the power t dx. Here p is 2 tan x, so 2 tan integration 2 tan x dx. And what is the integration of tan x? That is your log of sec x. Now you can write this integration sign in power of sec x, so it will be log e log sec square x, and its value will be only sec square x. Okay, so after finding the integrating factor, you just write the solution z into the integrating factor, that is z into sec square x is equal to integration q into integrating factor. Q is minus tan square x into integrating factor is sec square x dx. So it will be z sec square x is equal to minus of tan square x and sec square x. That means if you substitute tan x is equal to t, then what will happen? Sec square x dx will be dt. So this is your minus of t square dt. Clear? So integrate it with respect to uh, t, it will be t cube by 3 plus c. Okay, now substitute the original value, replace this t with its original value, that is tan x. So it will become y inverse x square x plus tan y inverse x square x plus tan cube x by 3 is equal to c. So this is the solution of the given differential equation. Now come to the next question. It is x plus 1 dy by dx plus 1 is equal to 2 e raised to the power minus y. So here in q is constant, and with q there is a function of y, that is e raised to the power minus y. So first you divide the whole equation with y raised to the power minus e raised to the power minus y. So divide the whole equation, dy by dx plus 1 upon y 1 upon x plus 1 e raised to the power e raised to the power sorry, here dy by dx plus, okay, first you just make the coefficient of dy by dx unit. So divide the whole term by x plus 1. So it will become like this. Now your p is 1 upon, p is a function of x, that is 1 upon x plus 1 is equal to q is 2 by x plus 1 into y raised to the power n. Here y is a function of n, so it will be e raised to the power minus y. Okay, so this is your given equation, but this equation is again equation in the form of Bernoulli's, known as Bernoulli's equation, and here y to the power n, the function of n is e raised to the power minus y. So divide the whole equation by e raised to the power minus y. It will be y square y raised e raised to the power y dy by dx plus e raised to the power y upon y x plus 1 is equal to 2 by x plus 1. Now substitute this e raised to the power y is equal to z, so it will be e y dy by dx is equal to dz by dx. So dy by dx is this e raised to the power y will come here in the denominator, so it will be 1 upon e raised to the power y dz by dx. So this equation 2 will become like this: dz by dx plus p into p. It was like this, no? So e raised to the power dy by dx will be dz by dx plus 1 upon x plus 1 in e raised to the power y will be e raised to the power y will be z. So it will be like this: z by x plus 1 is equal to 2 by x plus 1. Now you can see this is linear in z, where p is your this 1 upon x plus 1 and q is again 2 by x plus 1. Both are the function of x alone. So find the integrating factor. Integrating factor will be e raised to the power integration p dx. Here p is 1 upon x plus 1 dx. So and the integration of this is log of x plus 1. So write as log of x plus 1. So it will be only x plus 1. So integrating factor is x plus 1. So multiply the equation by integrating factor, we get the solution, and the solution will be as follows: z into the integrating factor, that is z into x plus 1 is equal to integration q into integrating factor. So this is q, this is integrating factor dx plus c, and this x plus 1 will get cancelled, and you will have the solution as e raised to the power y z plus 1. Okay, sorry, x plus 1 is equal to 2x plus c. So this is your required solution. Now this is your given equation: x square y dy by dx is equal to x y square minus e raised to the power minus 1 upon x cube. Now first write what is your dy by dx. divide the whole equation by x square y. Left hand side will be dy by dx is equal to, if we divide this term by x square y, it will be uh, y by x, okay, minus e raised to the power minus 1 upon x cube by x square y, okay. Now this will be y by x minus, here you can see that it is function of x is e raised to the power minus 1 upon x cube by x square, and y raised to the power minus 1, that is 1 upon y, is your y to the power n, okay. Now bring this term the left hand side, it will be minus of y by x, so p is your minus 1 upon x, which is a function of x only. P is minus 1 upon x into y is equal to q, and here q is your whole term in x into 1 upon y, okay. Now substitute, now divide the whole equation by this y uh, to the power y raised to the power minus 1. So if you divide this, it will be y dy by dx minus of 1 upon x. If you divide this equation by y to the power minus 1, that means we are multiplying with y, so it will be minus of y square. So it will be y square is equal to 1 upon y to the power minus y to the power 1 is nothing but y inverse. So it will, you are left in the right hand side with only the term minus e raised to the power x, 1 upon x cube by x square, okay. So the substitution will be this one y square, you have to substitute as a new variable z. So substitute y square equal to z, what will happen? It will be 2y dy by dx equal to dz by dx, only y dy by dx will be 1 by 2 dz by dx. Now substitute this value over here, you will get, in this place you will write 1 by 2 dz by dx minus of 1 upon x into z is equal to q is your uh, minus of e to the power minus of 1 upon x cube by x square, okay. Now you just write the dz by dx as a coefficient, its coefficient should be 1, so it multiply the whole equation with 2, you will get dz by dx minus 2 by x z is equal to minus 2 e to the power minus 1 upon x cube by x square. So now this is your p minus 2 by x. So integrating factor will be e raised to the power minus 2 by x dx. So it will be 2, if you write 2 outside the integration sign, so it will be minus of 2 log x. If you write this minus 2 in power of x, so it will be log of x raised to the power minus 2. Now x, it will be only x raised to the power minus 2, that is 1 upon x square. Now what is the solution? The solution will be z into, sorry, the solution will be z into the integrating factor. This is your integrating factor. So z into integrating factor is equal to q. Q is whole this term, q into the integrating factor into dx plus c. Now z by x square is equal to minus of 2, and here what will happen, here you can mm, write it like this, x raised to the power minus 4 e raised to the power minus of 1 upon x cube. Now substitute x raised to the power minus 3, this is x 1 of minus of 1 upon x cube means e raised to the power minus of x to the power minus 3. Okay, now substitute x minus 3 is equal to t, then what will happen? It will be minus of 3x raised to the power minus 2 into x, so it will be minus 3x raised to the power minus 4. Okay, if you differentiate this with respect to x, what will happen? X to the power n, the formula of x to the power n, if you apply, so it will be n x n minus 1, so it will be minus 3x minus 3 minus 1, that is minus 4 dx is equal to dt. So only x raised to the power minus 4 dx will be minus of 1 upon 3 dt. So write here as x raised to the power minus 4. This is your x raised to the minus 4 dx. This x raised to the power minus 4 dx is minus 1 upon 3 dt. So write 1 upon 3 dt, and this is nothing but e raised to the power minus of t. So e raised to the power minus of t dt. Okay, now this integration is very simple. It will be minus of e raised to the power minus t. So uh, it will be like this: x z by x square equal to minus 2 by 3 e raised to the power minus t plus c. Now put its original, substitute the original value, you will get z by x square, y square by x square plus 2 by 3 into e to the power minus 1 upon x cube equal to c. So this is your solution of the given linear differential non-linear differential equation, which can be reduced to linear form by the following substitution: whatever coefficient is q having, you just divide that power of y to the power n, uh, the whole equation you divide by y to the power n, and then whatever be the coefficient of p in terms of y, you substitute that is equal to z, and then find dz by dx. I hope you all have understood it. So thank you for watching the video. Have a nice time ahead. Thank you.